Awesome. Well, and part of this is I'm particularly interested in having Bret here today. Bret is actually the host for the Titans of Nuclear podcast. So this is a podcast idea that Bret functionally, as far as I understand in conversation with him, this podcast came to mind when he wanted to start talking to world leaders in general in the nuclear industry about why nuclear was not making the impact or having the presence currently that functionally it kind of needs to address climate change and some of the concerns that are coming down the pipeline very aggressively. So as a complete outsider in the field, I believe your master's was in mechanical engineering out of Stanford, he decided, I'm going to set up this podcast and start talking to people. I think that's just a fantastic idea. And so Bret has been doing, gosh, we're at easily more than 100 podcasts right now. Is it nearly 200 podcasts?
We're at 125.
125, okay. So at 125 podcasts right now, and has plans on at least a few hundred, but plans for up to 2,000. He's got a list, a spreadsheet with everybody to talk to. And what he's going to talk to us today is about some of the findings that he's had and kind of in his conversations with these titans as to what the role of nuclear moving forward. And I think this should hopefully be a more optimistic seminar maybe than sometimes what we hear coming through here. So without further ado, please welcome Bret.
Thank you for having me. So we're going to start off today's conversation with the assertion that climate change must be reversed by 2040. I find the goal to slow it down by some vague point in the second half of the century to be both cruel to those affected in the interim period and also totally uninspirational. To rally a nation, we said, let's go to the moon. We didn't say, let's get some of the way there and see what our plans are at that point. If we do not reverse climate change by 2040, we are risking unimaginable human suffering. Forget hurricanes, flooding, wildfires, these are all bad, but they kill hundreds of people. What will result in hundreds of millions of deaths are rapid changes to access of food and water. Now, I didn't jump straight to the word drought, as experts will argue that food production is both a combination of precipitation and soil evaporation. But let's keep it simple. Drought is the problem. And also keep in mind that food security is at jeopardy, even if changes to precipitation yield on average more productive land in the long run, but either create local deficits or the changes happen quicker than populations can adapt their agricultural infrastructure and processes. When there were 3 consecutive years of unexpected drought in Syria, it drove 2 million people into simultaneous migration. There's debate about whether this triggered the subsequent civil war and migrant crisis in Europe, but there's no debate that when you can't adapt quick enough, you have to move, and you become a climate refugee. And if we don't reverse climate change in the next few decades, we will see up to 2 billion people, the sum of any poor population where drought risk significantly increases, face that very situation. If we can all agree that the second and third order consequences of the Syrian drought were pretty horrifying, just imagine multiplying that times 1,000. We can't wait until the end of the century. Geoengineering doesn't solve this either. It might slow warming, but when it comes to changing precipitation patterns, it might actually exacerbate the issue. That's the premise of my timeline. Reverse climate change fast, instead of slow climate change slowly. And the technologies that we will discuss will be predicated on that requirement of achieving net negative carbon globally in less than 20 years. Now, you don't actually have to believe even that 2 billion climate refugees is worse than expensive energy. After all, human prosperity is attributable to the burning of fossil fuels more than anything else. That's a dirty secret. Every product that is good for humanity, buildings, medicine, food, it's more accessible the cheaper energy is. One could even make the argument that in the face of climate change and air pollution, the benefits of coal, gas, and oil still outweigh the costs. In fact, just about every country through their actions implies this very thing. But if you agree with my premise that human suffering is bad, the goal should be to reverse climate change and energy should be as cheap as possible, then the rest of this talk will be logically consistent with that framework. Under those criteria, I will argue there is only one possible path towards reversing climate change in less than 20 years. And it doesn't require technological leaps. It doesn't require efficiency. It doesn't require new taxes or new policy. It doesn't require any change in behavior whatsoever. That's why it's the only path that works. Agnostic to what technology creates the energy input, the only thing that you have to do to achieve all three of my goals, avoid human suffering, reverse climate change fast, and produce the cheapest possible energy, is to make carbon negative fuels that are cheaper than carbon positive fuels. Before we get to how that's possible, let's come back to why I keep saying reversing, just to understand the dreadfulness of choosing any other path. With 400 ppm already in the air, we would be accelerating towards climate change without any additional carbon. Imagine we're driving a truck. At this point, we are accelerating towards a cliff, down a hill, pressing the gas with those least responsible in our path. Despite any progress so far, every year we are actually still pushing the gas pedal harder. And when people talk about the dream of 100% clean electricity in the US, keep in mind from a carbon perspective, that wouldn't even offset global growth. 100% clean electricity worldwide, that's still pushing on the gas just 75% as hard. Electrify all transportation as well. That's still pushing on the gas, just 50% as hard. You're not even letting off the gas until you have decarbonized the entire world's electricity, transportation, heat, and industrial processes. And even then, you are still flying down the hill at your last speed. Anything but full-on reversing is the equivalent to condemning hundreds of millions to migration or death. Bill Gates recently called for radical innovation in each of those sectors by the end of the century. What kind of vision is that? There are billions of people still living in huts and burning cow shit to cook, and Bill Gates wants them to implement energy-efficient buildings? New technology across 1,000 industrial processes will not solve the most pressing and immediate problems. Nothing but a technology that reverses emissions using existing infrastructure solves the problem fast enough. So unless you build hydrocarbons in the exact form of the fuels we use today, there's no realistic path towards deployment on a timeline that can prevent catastrophe. You expect the world to throw away 1 billion working cars? What about the tens of thousands of fossil burning factories out there that already took on $1 billion investment over a 40-year period? They're just going to shut them down? This is why I say reverse. Carbon negative fuels is actually switching gears in my analogy. And if it is the cheaper option, then it doesn't require any sacrifice. Hell, leave the lights on, all you want. If you are burning carbon negative fuels, the more humans do what they already love to do, consume, the faster you will fix climate. It's the perfect alignment of incentives. No behavioral changes, no taxes, no policy changes, no self-restraint, and it can instantly be applied worldwide. It's just market forces and human prosperity. There is one catch, though. In order to make carbon negative fuels cheaper than carbon positive fuels, you need a different source of energy that is both incredibly dense and incredibly abundant. You need to use the strong force. The force within the atom. The potential energy released by the strong force is 6 orders of magnitude more powerful than breaking a chemical bond. Dense, check. The fuels for the strong force are 25 times more prevalent in the crust of the Earth than fossil fuels are. The ocean literally leaches it out with no binding necessary. Abundant, check. We are talking about nuclear energy. And there is not a person on this planet that argues that you can replace the world's supply of fossil fuels with carbon negative fuels at a cheaper cost in 20 years by any other path. And there is at least one that argues that with nuclear energy it will be simple. I know it feels good to virtue signal your tribal alignment with renewables. All your friends love it, the media loves it, they're shiny like Apple products. And don't get me wrong, they are great for clean air, but the most wildly optimistic scenarios for solar and wind, combined with the harshest of global taxes and the strictest of policies, might clean up just the electricity sector sometime in the second half of the century. Remember, when it comes to carbon, that is still barreling down the hill with your foot on the gas, taking out women and children along the way. Nuclear energy, I argue, can get us there in less than 20 years without any technological breakthroughs. I'll clear up one quick thing for those asking themselves what actually are carbon negative fuels. Well, there's no technology breakthroughs here either. You're just building hydrocarbons with way more energy than you get from breaking them. You take the CO2 and the H2O from either the air or the ocean, you jam a ton of heat into it, rip off some C's and H's, you recombine them into fuels and plastics. The fuels replace fossil fuels. The plastics sequester the carbon. Voila, carbon negative fuels. The one and only thing that you need to do to reverse climate change in less than 20 years is build a cheap nuclear plant in less than 5. I will be even more specific. If you are able to build a nuclear plant with less than 2 years construction period at $50 a megawatt hour, market forces will solve the whole problem from there. A 2-year construction time, because otherwise the capital risk drives up your financing costs and plays an outsized role in your final levelized cost of electricity, and $50 so it can compete in a critical mass of markets today. Those numbers aren't precise, but you get the point. So long as you keep your product consistent from there, every time you double production, you get a 20% discount in cost. So let's say at the end of the first 10 plants, you're really in your groove, and you've nailed that $50 a megawatt hour. At 20 plants, you're at $40 a megawatt hour. South Korea and France both took it that far. But no one's really built more while keeping the design consistent. At 160 identical plants, you are at $20 a megawatt hour. For something that operates day and night, that is the cheapest electricity that's ever been created, and it's 3 times cheaper if you're selling the heat. So now, here's where it gets interesting. By your 1200th nuclear power plant, you are at $10 a megawatt hour. Cheap enough to build cost-competitive, carbon-negative fuels. At your 10,000th nuclear power plant, you are at $5 a megawatt hour, and the world will see abundance like never before. Right now, your mind is probably jumping to one of two places, and I will address both. The first is probably, why doesn't this work with renewables? And the second is, what about all the problems with nuclear, waste, safety, etc. You can't do it with renewables for a simple reason. Capacity factor. If your supply is intermittent, and you can only run your carbon negative fuel production facility at, let's say, a 20% capacity factor, no matter how cheap you get your energy costs, your CapEx contribution of that plant is now 5 times more prohibitive. And that drives up the cost of your output to be uncompetitive. I know that's a bit complicated to digest in one sentence, but it's like your friend who says that we should power cars by putting a windmill on top. The math just doesn't work. And the problems with nuclear: waste, safety, radiation, public perception, regulation, supply, proliferation, and cost. Well, cost is an issue. And I would argue that that is the only problem that needs to be solved to reverse climate change. The rest, they're mostly either misunderstandings or outright myths. During the Q&A, I'd be happy to dive into any of those. But if you are using nuclear to produce fuels, it doesn't need to be co-located with the energy demand anymore. Which means that whether you think those are problems or not, they don't have to be your problems to worry about. You can just buy synthetic fuel from a country that wants to do this. Now, here's what I can tell you about cost. Nuclear used to be much cheaper, and they used to build the plants much faster. But to tackle these problems, you must recognize that today's costs are driven by construction management and supply chain challenges, not technology ones. So now I'll tell you a little bit about why I'm here. I started the Energy Impact Center to make sure that when it came to climate, we were solving the right problem. I learned from my former life in startups and really life in general, that's the only thing that matters. Solve the right problem. Once our team realized that the only way to prevent an upcoming refugee crisis that would make the dark ages look like a trip to the park was cheap nuclear, we set out to understand why it is so expensive today. That's what the podcast is really about. At the Energy Impact Center, we interview hundreds of experts in order to illuminate the extremely complex interdependencies of the various aspects of nuclear technology, processes, and culture that drive cost through its deployment. In the last year, we have met with 865 such experts across the following disciplines: national labs, startups, academia, thermodynamics, fluids, mechanics, chemistry, civil, seismic, material science, metallurgy, core design, power plant equipment, advanced manufacturing, fusion, nuclear physics, nuclear medicine, safety technology, health physics, developers, project management, construction, mining, enrichment, spent fuel, transportation, security, decommissioning, utilities, environmental compliance, historians, economists, government, project finance, venture capital, philanthropy, insurance, current regulators, former regulators, international regulators, accountants, export licensing, international trade, non-proliferation, communications, media, think tanks, environmental groups, lobbyists, authors, activists, trade groups, societies, and even lawyers. It is difficult to build a nuclear plant. There are a lot of moving pieces. It is very confusing. So we are meeting people and publishing our findings so you, the entrepreneur, can get the basic gist of each discipline, and when you want to learn more, you now know who to ask. It is hard, it is confusing, but is the only path that meets all 3 of my requirements: avoid human suffering, reverse climate change fast, and produce the cheapest possible energy. It is hard, but the reward is incredible. Whoever solves those problems not only stands to capture a $6 trillion a year energy market, but clean the Earth's air, desalinate unlimited water, and launch humanity into an era of unprecedented prosperity. It is hard, it is confusing, but I will make it simple for you. All you have to do is build a $50 a megawatt hour nuclear plant deployable in 2 years or less, and then keep doing it over and over and over and over again. You won't be alone. Those who work in this industry tend to be the most dedicated, intelligent, and honorable people that I have met. So if you are up for the challenge to make nuclear cheap again, and want to learn the secrets of the atom from those that keep it safe, go forth and meet those titans of nuclear. Thank you.
Thank you. Let's hear questions, Q&A. Open this up. So, Hunter kind of, and we'll start off with Andy.
Okay, so you mentioned a bunch of different sources of carbon. I forget what they were: industrial, electrical, transportation.
Yeah, I tried breaking the 4 categories usually. I mean, the pie chart looks different because like heat can be, industrial heat, or it can be residential heat, or heat can come from electricity. So, but the 4 that I like to break it up into are electricity production, heat, industrial processes, and transportation. And I view them each as roughly a quarter of the pie, but that's not exactly true.
So I was under the impression that a really significant source of greenhouse gas emissions is farming as well. Can you talk about that?
It has been characterized that way, that our agricultural processes, and there are a few different contributions that come from those agricultural processes. Some people like to talk about the methane that comes from cow gut. A lot of it actually is, there's a lot of energy input that goes into each acre of land also, so that takes a lot of fuel as well. And so part of the agriculture you can bucket into some of those categories. And then the methane, although I do think that needs to be solved, I've heard some very interesting ways to address that. Everything from capturing it directly from the cow and using it as an energy source, or changing their gut bacteria, or even if you're going to be pulling carbon dioxide from the air, pull the methane from the air also. And so that's why, I mean, my real thesis here is that we need to be doing direct air capture, or carbon dioxide capture from the water. We can start off with CO2 capture from plants as well. It's more dense there, and so it's a little more cost effective. But if we want to reverse, we need to be doing that. And so that's my real thesis there.
Sure.
So so in the general public, there's not always the greatest perception of nuclear. Do you think economics alone would be enough to overcome that?
I do.
Okay.
I think economics alone, and this is why I think it's important that if you're doing direct air capture, and then you are building fuels, and you're just selling fuels to everyone, it really doesn't matter what anyone else thinks. They'll buy fuels from you just like they'll buy fuels from Saudi Arabia. They don't need to know where they come from. And then you really only need one legal jurisdiction that agrees to your rapid deployment, or that encourages your rapid deployment, and wants to be fabulously wealthy beyond all belief to build all of your nuclear plants. You can literally site them, all along the coast of one country if you wanted to. You can put half of them on one island, half of them on another. I mean, whatever you want. That's the whole point. If the way that you're kickstarting this effort is you're building synthetic fuels. Doesn't matter what 179 countries in the world think.
Oh, sure. Yeah.
So given the difficulty of finding like a suitable repository in the US for just the spec fuel we have now,
Yeah.
do you think it's feasible that there could be an effective way to manage the fuel?
Yeah. It's a good question. So the way that you phrase the question, though, is as if fuel is a bad thing, or spent fuel is a bad thing, or nuclear waste is a bad thing. I mean, I disagree with that very premise. It's a bad thing. We've made it a bad thing. We've made it a hazard. We've characterized it as a hazard. But it doesn't have to be a hazard any more than anything else that could be, like that table could be a hazard if you trip and fall into it, right? You can productize things. You can package up the spent fuel and you can use it in a million different ways. You can pull, radionuclides are literally magical versions of normal atoms, right? That can be uniquely used for tracing, for imaging, for fighting cancer. We shouldn't be viewing radiation as a bad thing. We should view it as everything else. In some cases, yes, it can provide a risk, but if packaged up properly and commercialized, it could yield even greater benefits. And so I don't even like to characterize waste as a problem. I think that we should be making more of it, and we should be productizing it, and we should be using it to help human health and prosperity.
Okay, sure.
I don't know how to phrase that question because, but right now we're putting carbon into the atmosphere. That's not good global warming and stuff, obviously. By taking some of it, so carbon capture and making fuel out of it and stuff, we're basically building an industry around getting carbon out of the atmosphere or oceans and stuff like that. Wouldn't we eventually, and I'm saying that that would mean that we have solved the current problems, but I'm saying way down the road, but wouldn't we eventually create another problem, like the opposite problem, where we deplete the atmosphere from the carbon that are needed, and we don't have another solution to actually put more carbon into them?
So if we're using the energy from nuclear to literally build hydrocarbons, it's one of the least efficient things that you can do with the energy. Eventually, you want to have use it directly for electricity generation. You want to put it where all those fossil factories were. You want to use its heat directly, right? That's when it's most cost effective. It's least cost effective when you're just building hydrocarbons out of the air. So I imagine this is a temporary stopgap before we move to a hydrogen economy or nuclear power or more electrically driven devices or industrial processes. I'm focused on the 20-year picture. My whole argument is focused on that we need to solve this in 20 years and that we can't wait. And that is where I've driven these requirements for building the system that I imagine. First with carbon negative and carbon neutral fuels, and then once we get to a place where the atmosphere is what we think is the most stable, that'll have bought us plenty of time to have rebuilt other industries and processes to utilize the heat and electricity directly. Yeah, thank you.
Okay, Mark, yeah.
Okay. So right now, worldwide,
Yeah.
nuclear provides about 10% of the overall electricity.
Electricity, 4% of energy, yeah.
Yeah. Well, so, and if we take your pie chart and we say, okay, that's about a quarter of all the energy in the world, but if you want to say 4%, that's fine. So to me, then that says we probably need something like 25 times the number of reactors that we have, or at least the capacity.
Far more, because we need to. So we got to account for population growth over this time period. We also have to account for growth in human prosperity. So many people in this world are living in terrible conditions, and it's because they don't have access to energy. Right? Energy is everything. You have a toothbrush, right? You like your toothbrush? That's energy. Okay, it took energy to make that. And a lot of the world doesn't have access to energy, and I consider that just as much a crime against humanity as climate change is, frankly. And so, we need to solve the problem in a way that actually increases everyone's standard of living. And so we're going to do far more times.
Okay, all right. So what do you think? We need 100 times more reactors than we have right now?
Yeah, I think if we had about 10,000 gigawatts of always-on capacity, I think that would be a good shot.
Yeah, those gigawatts.
Yeah.
We're talking 10,000 reactors.
We're talking maybe 100,000 if they're 1/10 the size of the ones that we built today.
Yeah.
But
okay.
yeah.
All right.
But
way you want to.
Sure, but if you make them 1/10 that size, then and I'm not saying, and I'm not advocating for just taking nuclear plants and shrinking them. And I specifically didn't pick a certain reactor technology. But if you can imagine things getting smaller and smaller, and then you can imagine comparable systems that we build at that levels of production. Ford spits out 1 million trucks a year.
Sure.
Right? And so you can imagine if most of the components, and trucks are really complicated. Trucks are more complicated than nuclear power plants when you think about like the control systems and everything else, right? So it's like you can imagine a world where we have production factories spitting out all the necessary components and then being snapped together on a site somewhere in the quantity that we get the equivalent of 100,000 100 megawatt plants in the next 20 years. Yeah, we can do it.
In 20 years.
Oh yeah. Oh, we have to. Oh, we absolutely have to.
So
Right.
what
Oh, yeah.
so what happens then on the front end of the fuel cycle, right? So
Good
you
question.
built all these reactors, right?
Yeah,
We have-
buy uranium mine futures is what we need to do. Yeah, no, you're right. You're right. I'm hoping in parallel we're investing in uranium extraction from seawater and other technologies like that as well to be able to fuel these things. And by the way, I know I mentioned, hey, you can do it by just building the same thing over and over again, and that is true. But I don't think that's how it's going to go. Once you see the first 10 billion or 50 billion or 100 billion of money go into a new reactor, I mean, it will be how like a lot of people like to talk about the tech sector, right? This is going to be like the sector everyone talks about, everyone innovates in. All of these, like I'm not saying it has to be just one reactor design, but if you start that process, you're going to see a lot of innovation in the space. You're going to see a lot of other technologies that crop up around that, and so it might even happen faster.
Yeah, I'm just curious, Brett, and of course, in all of your interviews, you've been exposed and evaluated every conceivable kind of nuclear cycle you could imagine. Do you have a favorite out of this that you think has the potential to get down to the cost levels you're describing?
You're putting me on the spot, Pete. Okay, so like I said, I think there's going to be a lot of it. Once you start building these things and people realize how profitable it is, there's going to be a ton of innovation. And I think that opens up the realm to all of these advanced reactor designs that you see, and will create little markets for all of them. I mean, I love them. Like, I love them all. I mean, they're so innovative. Like, the different ways that with fossil fuels, you just light it on fire, but with nuclear, it's like, it's awesome, right? There's like so much more to it, to the core, and different like combinations of fuel and moderator, and then like within the fuel space, there's like so many, you can bind uranium to this or metallic or oxide. I mean, there's so much you can do. So I think there's just going to be like, I think they're all great, or most of them are great, the ones that make sense. What I think is important to get started with is probably a light water reactor, and here's why. Your standard light water reactor, you can utilize existing supply chain. I think a lot of the problem, right, that has been in both the nuclear industry historically, and even today, some of the challenges that maybe some of the startups aren't really considering are supply chain challenges. With your standard light water reactor, I mean, there are a lot of, especially if you make it smaller, there are a lot of companies that can build pressure vessels, a lot of them. You want fuel? You want 1 to 5% enriched fuel? Call up GE, Framatome, who they'll be happy to sell it to you. They'll get it to you. So I think what you want to do probably is start off with a design that doesn't have anything in it that doesn't currently exist in like the supply chain infrastructure of the world today.
Well, the current, I think I'm right, that the current operating plant in the United States, the average is $34 per megawatt hour. So well under your 50.
Yeah, that's the
for
operating.
existing.
Yeah, it's for the existing ones operating. Yeah.
At least I'm not aware of a light water design that's on the books today that would come in at less than probably 3 times that for a new reactor.
Oh, I know. It's crazy.
So
Yeah, it's crazy. So.
You're describing a real challenge.
Oh, I know. Well, but they built them cheaper in the 60s and 70s than they build them today, and that was with like old construction equipment and like worse construction practice. I mean, if you look at a modern construction site today versus one that existed in the 60s and 70s, the fact that they built them cheaper, like the overnight cost delivered cheaper back then than today, it is a crying shame. It means something has gone wrong in the construction management. It means something's gone wrong in the initial blueprints that we give the construction companies and how we hand it to them. I don't think anything is inherently wrong about a pressure vessel with water in it with uranium fuel assemblies. I don't think anything's wrong with that part, but I do think how everything else has come together, yeah, it's just gotten worse and worse and worse over the years. Part of this isn't, by the way, just specific to nuclear. Every they've got a rule of thumb when it comes to mega infrastructure projects. If you have over 3,000 employees on your construction site at any time, you can expect your final delivered cost to be at least twice what you sold that project as. Okay? That everyone in the construction industry knows. So if Westinghouse is going to put forth a design that requires 6,000 people on a site at any given time, and they're promising one number, you can expect to double that. That's the first problem. So if they can start addressing things like that and say, okay, we will not build a power plant that requires more than, let's say, 1,000 construction workers to be on the site, you're addressing the capital risk portion, which, by the way, dominates your cost of electricity. Half of the cost of electricity for these power plants that have run so far over budget, half comes from just the interest earned on the loan that you took out to build that power plant in the first place. Okay, and so that's why I said 2 years, because that addresses that problem. So you got to design the system to build it fast.
And so maybe I'll go ahead unless you have further questions, Pete. So one of the things maybe I'll push back on. Yes. So the idea that this could be done without changing policy.
Yes.
Because I completely agree with your thesis that the economics of this transcend why we are having issues in nuclear development today. And I think some of that does stem from how some of our current policy is set up as far as within the NRC, as far as how these things are licensed. And so what do you really believe that this can be done without changing policy, or I would think that would have to be some piece of the equation to address this.
I think with minor changes in policy, so okay, when I say change in policy, I mean like we don't need to like all lobby our congressmen and like have this huge effort to like unroll some crazy amount of regulations. That would definitely help, but I don't think we need to do it. I think in the US it is possible even without changing policy, though like, small changes in policy might help. I think it's much more likely to happen abroad. It's very easy to just get into a very US-centered mindset and expect that all of our experiences, whether they be with innovative new technologies or construction, whatever you imagine the system to be here, how you imagine life to work here, does not apply when we go to other places, okay? And so it might make sense to get this process kick-started in another country.
I think that's functionally what we're seeing right now happen, right? China's really launching much in the regards of nuclear development and things of that nature, and we're being a little bit behind here.
Right. If China keeps getting better and better at building these things and builds a more and more robust industry, and their innovators get the capital that it takes to deploy new projects, we might all be buying Chinese power.
So I heard one interesting piece of this, though. So at one point, I had the opportunity to hear I believe he was the former NRC chairperson, Dale Klein, talk, and he was just addressing kind of a group of students. And somebody had asked him where they thought that the next nuclear accident would happen. And he predicted China, because basically the safety culture and the speed with which they're moving forward with this sort of thing. And so while I agree that in general with the current status of things that economics are limiting factor, at least within the US as far as how things are structured, what are the ramifications if you have somebody marching forward so quickly and then something happens? And what does that change the landscape then, as far as all of a sudden it isn't just economics anymore, and this has caused a real problem as far as our ability to operate in the space. And it's not something that's
it's hard to predict, but
I'm sure.
But if I were to put my money on what would happen in China, if they had a 3 Mile Island incident, nobody would even know about it.
Well,
they would just shut that down. They might even just yank out the reactor and put in a new one, right? Bury the reactor.
Sure, 3 Mile Island would probably be one, but if they had a Chernobyl, which they tried to keep under wraps, and they couldn't.
So I don't think anyone would have a Chernobyl-like situation with a light water reactor. I just don't think the physics support getting that much shit up into the atmosphere. But
I'll defer to my reactor design colleagues to back that up.
but let's say a Fukushima type.
Yeah.
Once again, let's say that you got to the point where you had a full meltdown. I don't think that in China they would have waited 3 days to depressurize the containment vessel or start pumping in seawater. So I think it's very easy to shit on China sometimes too, but they've got a lot of brilliant people who manage things extremely well, and it's very hard for us to understand how they do things because we're very involved in our culture, our safety culture sometimes too. And I think sometimes our safety culture isn't always the safest, even though we profess it to be. There's other safety paradigms, and China actually might be better at them than us, and we just might not be recognizing it because maybe we're a little jealous that they're building 20 nuclear plants and we're building one now, maybe if it finishes.
Based on now I will agree that we kind of have a tendency to shit on China, but based on some things, I would say they may do some things better safety culture-wise, but I'd say probably there are more instances than not when people are kind of coming into labs and starting to do some things. You're like, okay, that maybe, and maybe that's, but other questions now that I'm kind of Andrew.
You talked about building thousands of nuclear plants. Can you just speak to the proliferation potential risk of that?
Yeah.
And how you would deal with that?
Yeah. Proliferation, I think, is very misunderstood. So it took me 400 interviews, obviously not all on this topic, but to fully understand that light water reactors are pretty naturally proliferation resistant. And that's because of the plutonium-240 buildup relative to the plutonium-239. Listen, a real technical expert could push back on that, but let's just say when you're considering the total cost of a system of a terrorist building a bomb, it's pretty proliferation resistant that way. So I don't think that you're increasing the proliferation risks if you're building reactors that don't have in situ refueling, where you could easily get burn some Pu-239 real fast and get it out of there. So I think that is a consideration, and so we should be keeping our eye on that. We keep our eye on all proliferation avenues, and we should make sure that those types of plants don't get built.
Sure.
So Andrew's question is actually really important here because it's not just the phase inside the reactor that matters. You have the front end of the cycle as well and the back end of the cycle.
Yeah.
And so this drives a lot of discussion regarding should country X have enrichment capability.
Oh, yeah.
Enrichment technology.
Oh, I don't want anyone to have enrichment capabilities except for us.
Okay, I was going to ask.
Oh, yeah, no.
But I thought China was safe. No, I'm
Oh,
kidding.
yeah. No, I hate the idea of other countries having enrichment capabilities. I wish it was all here and it was really tightly controlled under. That's the part that I think should be controlled under,
Yeah, I was
Blocking
going to
it.
ask if you envision enrichment and reprocessing
No.
being
Like I said,
distributed around the
no,
world or more
no.
centralized.
No, so definitely centralized, and you can ship your fuel to whatever sites these are at. And like I said, in this vision where we're doing this all in 20 years and building, 10,000, nuclear facilities, a lot of, if we're doing direct air capture, a lot of them can be co-located in the same place. And so that place could be where you do your enrichment also if you really wanted to.
So let's see, how are we doing on time?
Plenty.
We got plenty. We got a few more
Keep 'em
minutes
coming,
for any
guys.
other questions. Yeah, no, I think this has been a healthy discussion. Ian.
If I can bring it to the back end of the cycle.
Yeah.
again.
Yeah.
So you mentioned that basically you think that the market would take care of the majority of the spent fuel.
Yeah. Oh yeah.
And I'm not familiar with the intricacies of the NRC's rules on managing spent fuel or using it for other purposes.
Yeah.
But from how I understand it, the market has not come up with a reasonable use for it in 70 years. So I don't know if it'd be reasonable to expect that they would come up with it. And knowing how difficult it is to separate all the isotopes that you want to use from nuclear fuel.
Yeah.
Do you think it's really worth the risk of creating that much fuel?
So once again, I don't think it's a hazard to human health. I don't think spent fuel is a hazard to human health. Period, hands down, end of story. Once it's in a dry cask outside your plant, no one's touching that thing for 100 years if you don't want to. So I don't think it's any hazard to human health. That's first and foremost. In terms of why we haven't done it already, that's pretty complicated, and also comes back to, yeah, how do you get your hands on spent fuel? I've asked a lot of people that exact question. A lot of people want to productize it and literally cannot figure out how to get access to it. It's a little challenging, but if, once again, in this vision that I paint, where we're building thousands of nuclear reactors and it becomes the most robust industry on planet Earth and the most profitable industry on planet Earth, somehow I think it'll get taken care of, yeah.
Well, I might follow up on this, just especially since we have some real experts from any kind of stuff in here. I mean, I imagine one of the limitations in being able to manage the fuel and processing it is that we aren't legally able to process the fuel, right? I mean, that would maybe be one other policy change that would need to happen. Is that correct, Peter?
It's not that you can't do it legally.
Yeah.
It's that the only way that is funded by the government is Yucca Mountain. And until Yucca Mountain is licensed, nothing else happens. So if somebody wants to start a reprocessing facility, they're gonna do it all in private money unless the law gets changed. But I wouldn't say it's illegal.
It's not
I would just
illegal,
say
it's just
it's
not,
really
okay.
expensive.
Yeah,
Gotcha.
and the other problem is that the fuel is the responsibility of the government, so. Right, I mean, disposing of it, we, as a nation,
And trusted.
agreed that we'll take the fuel and do something.
Which I think in retrospect was incredibly stupid, but that's what we
We
did.
did, right? And so, you know, the impetus to do something winds up being on the shoulders of the government, right? And it becomes our collective responsibility rather than some entrepreneur's responsibility. Now, wouldn't it be great? Imagine being able to say, taxpayers, you know, we're gonna sell this resource to this private concern that's gonna process it, make a
Schaefer
product.
Engines and
Yeah, that's
consulting.
right. Make this product and turn around and sell it back to you, right? That the product you want, right? So, but, I mean, you're totally right, Pete. I mean, we have this problem that, you know, Ronald Reagan came along and he said, okay, no, you can reprocess, right? I mean, we're gonna stop this Carter nonsense, but at that point, we had no more momentum. And soon after that, the modern low-level waste and the high-level waste policy acts passed in the early 80s, and then now that set up Yucca Mountain. So.
I think we could have a repository decades ago with the responsibility that be given to industry and not the government.
Well, right, they don't want the stuff on their site to be, every year they're suing the government to pay them
And the
for
countries
keeping
that are moving ahead with repositories are doing it through private structures, not government structures.
Sorry.
No,
Oh,
I
it
think
is,
I mean, part of it was I wanted to get
Well,
some
I mean,
feedback on that.
Just to add to that, reprocessing right now is really expensive.
Yeah.
If you look at things like Repercussion in Japan, and last I heard it was 26 billion counting, and still has yet to be open. So the history on reprocessing, let's say at least complicates your vision a lot. I don't want to say it can't be done.
Sure.
But it's.
Sure. And I don't
It's
consider,
as
yeah,
long
and I don't consider productizing the waste an intricate or an essential, integral part of the vision. And I also don't imply that productizing requires reprocessing.
Sure, yeah.
It's still producing heat. And heat is useful as a product, and so you could imagine, you can imagine a ton of uses for just very low level heat that maybe aren't that profitable, but in theory, productize it and get it off people's mind as something that needs to be disposed of and something that's generating revenue.
All right, anything else, guys, before we let Brett off the hook? Oh, one more, Andrew.
I just think of like solar, and it feels like every couple of years the energy cost is like half of what it was just a few years before.
Yeah.
Do you see anything like that as possible with technological innovation in nuclear? So like anything of that sort to lower the cost?
So I think, first and foremost, I think that the construction side needs to be dealt with to lower the cost. But yes, once companies show that you can make a profit on nuclear, I think there's going to be a ton of technological process. I don't mean to say that there won't be. I think there totally will be once there's money in it. But I think first we need to get costs under control, show that it's profitable to sell nuclear power plants, and you'll see just a flood of R&D come into the space. Yeah.
Oh, one. Okay, sure.
So, is there an estimate for like what the final price tag would be for all these 1,000 or possibly 10,000 reactors? And is there any, at least currently, any interest, like venture capitalists or anyone? Is there anyone throwing their money at this problem?
There is, but people are being a little secretive about it right now. I don't like that generally. I think it's a bit counterproductive. So, I started one of the earliest drone companies, and when I was in that space, I knew all the other founders, and we essentially had I don't want to say it was a strategy, but we had a mutual understanding that a rising tide floats all boats. So what we did was we actually created this competitive environment, created momentum, and created an expectation that drones were going to be the biggest next market, right? That's what we did, and then just tons of billions of venture capital poured into the sector, so it worked. And that's where a lot of my biases about nuclear come from now. I saw it happen in another industry that I was intimately involved in. And yes, so right now there are nuclear companies being funded to the tunes of, some of them have gotten hundreds of millions, but right now, today, there's some that are raising like 20 million here, 20 million there. They're not talking about it. I think they're doing a disservice to themselves. I think they should be like amping up the profile of nuclear, and you'll see a lot more money flow into this space. Right now, if you were to look at these types of risk investment portfolios, venture capitalists who are allowed to spend money on out there ideas, what's sitting on their books is just billions and billions and billions and billions waiting to be invested, and they're having trouble finding enough companies to put it into because the software space is too saturated at this point. They're looking for new opportunities, but they're not quite all up to speed on the potential of nuclear yet. But once they do, once they get up to speed on nuclear, and once they see the potential, once they see the market opportunity, you can see billions and billions and billions of venture just pouring in.
Oh, Ian.
Actually, it's another question.
Yeah, please.
I want to shift gears to geopolitics.
Okay.
So I can see definitely something like this happening in the economy and the government space where the market drives a lot, but there are certain countries like Russia, for example, that loves how much money its gas industry is bringing in, how much control it has over Eastern and Western Europe because of that.
Yeah.
But also that they love climate change nowadays as letting the Arctic to create new shipping lanes. And so do you think that it's feasible, given an opposition that's almost certainly going to come from countries that are dependent on fossil fuels, to have this be successful, or successful enough that it actually reverses climate change?
That's a good question. That is a real concern, right? If there are a lot of negative interests, that are actively working against it, you don't know all the mechanisms and ways that they're going to work against you. You're right, that is a big concern. But not everyone takes every commercial threat too seriously at the beginning, and then sometimes, this is how big industries get disrupted. The little guy does something, the big guys say, oh, they'll never get it cheap enough, we've seen this before. And by that point, they've created enough momentum. And then the guys who don't like it start actually investing in it so they can get a piece of the action too. So sometimes it goes that way also.
So, all right, I think it ties into basically some of your early premises that you were given as far as you basically have to accept these three things. And if you don't, which kind of falls under what you're saying, right, is that what if this outside of that accepted premise occurs, then yeah, that could potentially cause some problems. So, but at any rate, well, let's go ahead and thank Bret one more time.